Hey everybody, it is lesson 18 and it is our final new lesson of Unit 7, which is crazy. Tomorrow during our normal lesson, we're going to be reviewing for the end of unit test. And then on Thursday, your assignment will be the test. Then on Friday, we'll review the test and we'll dive into new content starting next week. So I'm really excited to apply what we've been working on with greatest common factor and least common multiple. Today, we are using common multiples and common factors to solve problems that you might normally need to solve outside of math class. So story problems, word problems, things like that. Go ahead and update your notes. Make sure you're in a space where you can really focus, and let's dive in. We are going to start with a question about a party. But I want to kind of give you a heads up on some instructions, okay? As you work on, we're going to work on two problems. As we work on these problems, identify what kind of mathematical work is involved in each of the problems. Put an X to show what the questions were about. So we'll do one problem about a party and one problem about stickers. And we're wondering in these two word problems, do we need to find multiples? Do we need to find the least common multiple, or LCM? Do we need to find factors, or do we need to find the greatest common factor? Okay, so I want you to take a moment and write this down. I'm actually going to show you how I wrote it. I took a shortcut that you're welcome to take too. All right, so here's question one. Go ahead and copy down this table onto your notes. Those of you who have been uploading your notes as images are doing a really excellent job. So keep that up. I love looking at them, and I do look at them every day. And love to see those stars on your paper as well. So we have question 2 and question 3 here, and we're just going to be thinking about carefully what kind of work did we need to do in order to solve that story problem. Thinking about this is really going to help you as you go to transition to your independent practice today. One of the goals of today's lesson is that you can look at a story problem and just identify, not even solve, but just identify, is this a least common multiple problem or a greatest common factor problem? Okay. Please pause the video here if you need more time to write this on your paper. Otherwise, let's go. We're going to jump to number 2. Okay. All right, Elena is buying cups and plates for her party. Cups are sold in packs of 8, and plates are sold in packs of 6. Okay, she wants to have the same number of plates and cups. I've definitely been in a situation like this before where you need enough plates or cups, or like hot dogs and hot dog buns for a party. Okay. We are going to A, find the number of plates and cups that meets her requirement. B, how many packs of each supply will she need to buy to get that number? And then C, name 2 other quantities or amounts of plates and cups she could get to meet her requirement. Her requirement is just that she wants to have the same number of plates and cups. So she wants equal amounts of plates and cups, okay? All right, go ahead and predict now. Do you think we are going to be finding multiples? Remember that skip counting. Do you think we're going to find the least common multiple? Do you think we're going to find factors? So are we dividing these numbers up into their factors? Or are we going to find the greatest common factor? So the greatest number that could divide both amounts evenly. Go ahead and put an X in the boxes or box where you think that indicates what you think we're going to be solving in this problem. Awesome. Go ahead and compare your thinking with mine. I think we're going to be finding multiples, and I think we're going to be finding the least common multiple in this question. If she's buying packs of, was it 8 cups? If she's buying packs of 8 cups, let me triple check that. Yeah. If she's buying packs of 8 cups and she's buying packs of 6 plates, and I want an equal amount, I'm going to be counting by 8s to figure out the total amount of cups for how many packs I'm using. So she could buy 8 cups or 16 or 24. Those are called multiples. Those are called? Yeah, we're going to be finding multiples. Then when I'm thinking about the least common multiple, I'm thinking about a number of plates that meets her requirement or 2 other quantities. The smallest of those packs she could buy would be the least common multiple. So I am going to be finding that also in this question. I'm not going to be finding factors of 8, like how many, like what I could multiply to get to the amount of cups in one pack. That's not useful for this question. Okay? All right, go ahead and, like me, jot down how many cups and how many plates, please, in each pack. That helps me determine what am I skip counting by, and that helps me eventually find the least common multiple. So that's the first thing I want you to do. Go ahead and find multiples of 8 and multiples of 6, and circle any that are common. All right, while you do that, I'm going to get a timer pulled up. We'll just take 1 minute. Skip counting by 8s, skip counting by 6s. We're about halfway through our time. Go ahead and stop where you think is appropriate. Great work. Go ahead and pause the video here if you need a little bit more time. All right, so I went ahead and skip counted by 8s and by 6s. Please check your work here. One thing I sometimes see is that maybe you made a little skip counting error and that messed up the rest of your list. So go ahead and triple check and pause the video here if you need more time to update your paper. I continued until I had at least 3 common multiples. And I thought by the time I got to 80, I would have that, and I was right. 24 is a common multiple of 8 and 6. 48 is a common multiple of 8 and 6. 72 is a common multiple of 8 and 6. The other multiples of 8 in this list and the other multiples of 6 in this list are not common. They don't share multiples besides these 3. If we continued skip counting even further, we would find more and more and more common multiples, but we just don't need to go that far in this question. Okay, so let's look back and remind us what the question is asking for. A says find a number of plates and cups that meets a requirement. Okay, a number of plates and cups. So the only requirement is that she wanted to have equal amounts of cups and plates. So let's go ahead and write A. She could buy 24 cups and 24 plates. You could have also answered 48 here, or 72, or if you went even higher, a higher multiple. It didn't say find the least amount of each she could buy, it just said find a number of cups and plates. 24 is a great answer. B. B says how many packs of each supply will she need to buy to get that number? I'm going to read it one more time, then you think. How many packs of each supply will she need to buy to get that number? How many packs of cups will she need to get 24 cups? Remember that cups come in packs of 8. How many packs will she need to get 24 cups? You got it. She needs 3 packs. Please write with me. She needs 3 packs of cups. And let's think about plates now. Do you think it's more than 3 packs or less than 3 packs for plates to get to a total of 24? Remember that plates come in packs of 6. Do you think she'll need more than 3 packs or less than 3 packs? If you were thinking she needs more packs of plates in order to get 24 plates, you were right. That's because there's fewer plates in each pack. She needs 1, 2, 3, 4 packs of plates and 4 packs of plates. Please update your paper so that your paper looks like mine. Awesome. Let's do part C. Name 2 other quantities of plates and cups she could get to meet her requirement. Perfect. Well, we already have those multiples listed out, so all we need to do is jot down our answer. She could also buy 48 of each, or she could buy 72 of each. Go ahead and write your answer along with me. She could buy 48 of each or 72 of each. Nope, this isn't 48 packs of cups, right? It is 1, 2, 3, 4, 5, 6 packs of cups. Okay. And it's 8 packs of plates. But that gives us a total of 48 cups and 48 plates, which meets her requirement. Okay, let's try another one. Go ahead and set your paper up for question 3. Oh, I'm sorry. Oh yeah, no, we're ready. I thought I just didn't put this here. Sorry, guys. I got tricked. Okay. Reminder as we move on to the stickers question, as we read it, start to think about, are we finding multiples or the least common multiple? Okay. All right. Number 3, stickers. To celebrate the first day of spring, Lynn is putting stickers on some of the 100 lockers. That's an interesting total. I'm gonna bold it. Along one side of her middle school's hallway. She puts a skateboard sticker on every 4th locker, starting with locker 4, and a kite sticker on every 5th locker, starting with locker 5. Okay, I'm just picturing her skipping down the hallway, and when she passes locker 4, skateboard sticker, and then she keeps going. Okay. Our goal in this question is to name 3 lockers that will get both stickers. And we're also going to answer the question, after Lynn makes her way down the hall, will the 30th locker have no stickers, 1 sticker, or 2 stickers? Explain how you know. Interesting. What a good question. Okay, so now I want you to think, does this problem require that you find multiples, find the least common multiple, find factors, or find the greatest common factor? Go ahead and jot your answer in your table. Remember, multiples is like skip counting, and factors is like dividing. So are we dividing to find how many, to find the factors of 4 and 5, or are we skip counting by 4s and 5s to solve this problem? All right, if you thought that we were finding multiples and finding the least common multiple, you are right. She's going to be counting by 4s to figure out skateboard stickers, and she's going to count by 5s to figure out those kite stickers. I jotted down a couple of important details from the question. Go ahead and make your paper look like mine. All right, pause here if you need more time to update your notes. Let's go ahead and take 2 minutes to finish that skip counting. And then answer the questions. Okay, 2 minutes start now. You decide where it makes sense to stop. Note that there is only 100 lockers. Plus 20 seconds. Awesome work. If you're ready to review, stick with me. If you need to take another minute, pause the video. All right, so I went ahead and skip counted by 4s and by 5s. I stopped in my list for 4. I stopped at 68 because I could have continued all the way until 100 lockers, but I thought, I bet that there's enough multiples here to get me started at least. When I skip counted by 5s, that one was really easy. We always practice skip counting by 5s in elementary school, so it was super quick. And I went all the way to 100 lockers. Question A said, which lockers would get both stickers? In order to identify that, what I'm really doing is interpreting what these mean. This means that the 4th locker gets a skateboard sticker. The 8th locker gets a skateboard sticker. The 12th locker gets a skateboard sticker. The 16th and the 20th get a skateboard sticker. This list of 5s is which lockers get a kite sticker. So I noticed that 20 is on both lists. It is a common multiple. It is you got it. Locker number 40 is on both lists, and locker number 60 is on both lists. If you went all the way to 100, you would find on your list of 4s that also locker 80 and locker 100 would get both stickers. So my answer was locker 20, 40, and 60 will get both stickers. You should name 3. You could have also named locker 80 and locker 100. Part B asked, will locker 30 get 0 stickers, 1 sticker, or 2 stickers? I'm looking at locker 30 and I don't see it on my list for skateboard stickers. It's going to be in between lockers that have skateboard stickers, but I do see it here. So B, my answer is locker 30 will get a kite sticker, but not a skateboard sticker. Okay, let's keep going. All right, there are 2 more questions here. We're not going to solve these questions. We are just going to read them and identify if the problem involves finding common multiples or finding common factors, okay? Let's read together. Number 4, this is a problem about soccer. Diego and Andre are both in a summer soccer league. During the month of August, Diego has a game every 3rd day, starting with August 3rd, and Andre has a game every 4th day, starting with August 4th. What's the first date that both boys will have a game, and how many of their games fall on the same date? Okay, so do you think I'm going to be finding multiples, or do you think I'm going to be finding factors to answer this question? Remember that multiples is like skip counting. So do I want to skip count by 3s and by 4s through the month of August? Or do I want to find numbers that divide into 3 and 4 evenly? If you were thinking that this problem would require the common multiples and the least common multiple, then you were correct. Nice job. For number 4, we are not going to solve it together, but I do want to show you what my answer will look like. Just in case you were confused about why it's common multiple and least common multiple, okay? You do not need to write this down. Number 4, Diego's game was every 3 days, Andre's game was every 4. So for Diego, I skip counted by 3. Skip counted by? Yep, all the way until the end of the month, the 30th. And for Andre, I skip counted by 4, all the way until I got close enough to the end of the month. And I noticed that 12 and 24 are common multiples. So when I'm thinking about what days their games are on the same day, I know that Diego has a game on the 12th, August 12th, and Andre does. They do not both have a game on the 8th or the 4th or the 3rd or the 6th or the 9th, right? I also know they have a game both on the 24th, okay? So when I'm answering those two questions, that's how common multiple and least common multiple are helpful. I know that here's least common multiple. The first date they both have a game is August 12th, and two of their games fall on the same date. That's on August 12th and August 24th. Okay. Again, you don't need to write this down. This is just a proving why we said multiple, common multiple, and least common multiple. Okay. Let's look at question 4. Again, we're just going to decide what kind of mathematical work do we need to do to solve this problem. Okay. This is going to be in your Google form, so listen super carefully. This question is about performances. During a performing arts festival, students from elementary and middle schools will be grouped together for various performances. Grouped. That usually makes me think division. We'll keep reading. There are 32 elementary students and 40 middle school students. The arts director wants identical groups for the performances with students from both schools in each group. Each student can only be a part of one group. So can you picture I'm putting my 32 elementary school students into an equal number of groups, and I'm putting my 40 middle school students also into those groups. And I want every group to be identical number of elementary and middle schoolers, okay? So maybe you already have an idea of what kind of mathematical work we're gonna have to do. It's asking us to name all possible groupings, and it's asking us what is the largest number of groups that can be formed? How many elementary students and how many middle school students will be in each group? What kind of mathematical work do you think we need to do to solve this problem? Remember, multiple is skip counting. So do I need to skip count by 32 and skip count by 40? Remember, factor is about dividing into both of these numbers. So do I need to find a number that I can split 32 into and split 40 into? If you were thinking common factors and greatest common factor, you were correct. Really great job. We haven't done a problem like this one today, haven't done it since last week. So I'm really excited to review this one with you. I think it is probably a good idea for you to write this one down because we haven't done another example of greatest common factor. So go ahead and make your paper look like mine. I went ahead and found factors of 32. For example, I know that 1 times 32 is 32, 2 times 16 is 32, and 4 times 8 is 32. There was nothing 5, 6, or 7. Those don't multiply to get 32. I also found factors of 40. 1 times 40 is 40, 2 times 20 is 40, 4 times 10 is 40, and 5 times 8 is 40. 6 and 7 are here, but they're not factors of 40. I noticed that the common factors were 1, 2, 4, and 8. Pause the video here and update your notes. Awesome. So that first question, question A, said name all possible groupings. Okay. Here are the possible groupings that I could make. So it's asking really what are the common factors. I could have one group in the performance that has all 32 elementary schoolers and all 40 middle schoolers. I could also have two groups. That's the next common factor. I could have two groups with 16 elementary schoolers and 20 middle schoolers in each group. I could also have four groups with 8 elementary schoolers and 10 middle schoolers. 4 was the next common factor. And my greatest common factor is 8. I could have 8 groups with 4 elementary schoolers and 5 middle schoolers in each group. Okay. The second part of the question says, what's the largest number of groups that can be formed? How many elementary school students and how many middle school students in each group? We've already done all of that work. The greatest common factor, the greatest number of groups, is 8 groups with 4 elementary schoolers and 5 middle schoolers in each group. So this is the kind of question when I hear that dividing into my total amount, this is the kind of question that common factors and the greatest common factor is really helpful. Let's review the lesson summary, and then it's time for question of the day. Okay. Here is a lesson summary part of it. I want you to go ahead and read that silent solo, and we'll come back together in a moment. Okay, pause here if you need more time. The part I highlighted is the most important part, and I want to highlight just this sentence. If a problem requires finding the largest number that can divide into the two whole numbers, we're looking for the greatest common factor. That's like the performance, where we're splitting elementary schoolers and middle schoolers into groups. Go ahead and read this part of the lesson summary. Take a moment to do that silent solo. Okay, pause here if you need more time. I just want to highlight again, if a problem requires finding the first instance the two numbers share a multiple, we're looking for a least common multiple. We did that in lots of times today when we talked about cups and plates, when we talked about stickers on lockers, when we talk about the two friends sharing days that they have a soccer game. Okay, there's another example here about forks and spoons. Okay, here are your questions of the day. These are typed today, so hopefully it's really easy to get to the right answer as long as you're watching the video. We're just filling in basically what we read from the notes. This is the conjecture if we were all together and taking notes as a class. I would write down the question stem and the answer choice on your notes so that you have it for your test on Thursday. Okay. If a problem requires finding the largest number that can divide into the two whole numbers, we are looking for You're right. We are looking for the greatest common factor. So below this video in the Google form, go ahead and select for question of the day part 1, go ahead and select greatest common factor. Awesome. Part 2, if a problem requires finding the first instance of the two numbers sharing multiple, we are looking for crushed it, the least common multiple. Okay. Hopefully those examples were helpful. Your independent practice today is on the next slide of this Google form, and it is on assessments. Please make sure you're dropping by Mr. Zamora's office hours. And yeah, I think that's it. One thing on question 5, I just want to make sure it was super, super clear. On question 5, we were looking for common factors. I'm sorry. Yeah, and the greatest common factor. That's a typo. I'm going to fix it before you guys get this video. The greatest common factor. Okay? All right, team, that's it for me.